This week, Lab TV travels to an Air Force research lab in Dayton, Ohio, where scientists are developing an exciting new fuel from a very ordinary metal, aluminum.
Aluminum is an element. It is a very common material. You find it right here. It's used in many structural things.
Aluminum is a lightweight metal that's used to make airplanes, cars, bicycles, buildings, electronics, and lots of things you have around the house.
So aluminum is very common. We use it so many different places. It's also your soda cans.
In nature, aluminum is combined with other elements. It's much too reactive to occur as a free metal.
There's a very well-known reaction, the aluminum-water reaction. If you take aluminum, put it in water, the aluminum will oxidize. It'll take the oxygen from the water and it will liberate that hydrogen. The hydrogen will then come off as hydrogen gas, and you'll end up with an aluminum oxide byproduct.
The aluminum objects that we use, like soda cans, have a protective oxide coating that keeps this reaction from happening. And that's a good thing, because it's a powerful reaction.
The reaction is extremely exothermic. Okay, what that means, well, you have two things. You have exothermic reactions and endothermic. Endothermic takes heat to make the reaction go. Exothermic gives off heat when the reaction goes. This gives off lots of heat. If you want the number, it's 31 kilojoules per gram for aluminum to go to aluminum oxide. Lots and lots of heat.
Dr. Bunker and his team are working to harness the hydrogen released in this reaction. The key is creating aluminum nanoparticles that are stable in air.
Nanoparticle is something that is very, very, very small. Molecules, atoms, are on the angstrom level, so these are only a little bit bigger, just one order of magnitude larger. So these are about 30 nanometers or 300 angstroms, so we're only a little bit bigger than when you play with atoms. These nanoparticles have a protective coating on them that when we put it in water, it just gets out of the way. They start reacting with the water, strips off the oxygen, and hydrogen comes off.